has to leave for that? Does the band have to go too?
They all go at different times.
Okay. All right, cool. Here's your objectives. Feeling sleepy today. I feel my brain is deprived of oxygen and caffeine. You are too. You look like you're here, but you're not checked in, bro. Okay. Okay, here we go. These are just the different ways that you can solve a quadratic. One is you can do it by factoring. And of course, discriminant will tell you whether it's factorable or not. Sometimes that's the easiest way. It's fastest when you do some trial and error, or if you can see them already. But the one that's never going to fail you is going to be the quadratic formula. Okay? Even if they're asking you for the factors of it, you can do the quadratic formula and then reverse math it to get the factors out of that. But anyway, those are the four methods. There's some advantages, disadvantages. I think you guys know already some of those. Yeah. I'm not in there, am I? I was trying to. They all have their goods and their bads. I mean, the more you use them, the more you're going to know what you're going to want to gravitate to. Okay, so solving. We had, oh my goodness, your flash was pretty bad. I see a green spot now.
Oh, wait, was on?
Yeah, it was on. I was trying to pose, but
I'm blind. I can't.
as big as I was, I thought I'd be in there. Okay, this is going to be tough. This is just like what we did before with the rational equations. You're trying to get rid of those because what you're trying to get is something that's in the standard quadratic form. So for starters, you want to get rid of the denominator. First thing I need to know is what is that common denominator? And it's going to be x times x minus 1, right? X because those are two different numbers. This is some number, and that's one less than that number. So it could be like 9 and 8, 2 and 1, whatever. Just the one that's less than the other. So as you distribute out, the x minus 1s will cancel, so you're going to get 4x for the first part. As you distribute to the next part, well, this had a denominator of 1, which means I'm going to need all of it, like that. And that's going to equal, what cancels here? I'm not throwing my air quotes up anymore. I should. So this is what it comes out to. At this point, you want to just clean it up, get everything on the left side. So I'm going to start by expanding everything first. So 4x plus 9x squared minus 9x is equal to negative 7x plus 7. I want to make sure those two are on this side. So I'm going to add 7x and subtract, whoa, there was no, never mind. And subtract 7 out here somewhere, I guess. And that's a positive 4. So 0 on this side is exactly what I need. Let's put these in order. Here's a 9x squared. X's, I've got 4, 11, minus 9 is a positive 2x minus the 7. So that's what I would use to throw to the quadratic equation. And from there it's just did I mess something up?
It's negative 9x plus 7x would be a negative 2x, right?
The where?
Next to 9x squared. At the bottom.
That's a negative 9x?
Yeah.
Plus the 7 is negative 2.
So it's still negative 2, not positive 2.
But then there's 4x's over here.
Oh, okay.
I should have kept the colors. I'm sorry. I'm slacking today.
I forgot 4x.
Yeah, there's another 4x up front. Do I need to finish this with the quadratic, or you guys are good at this point? Anybody want to see it just because it's fun? Awesome. So, can I get rid of this work up here? You guys are okay with that? All right, so this is gone. And your calculator was correct.
How? How does that make any sense? Like, they got 64 and I got 56 and I think I got 8.
Well, because 2 squared is 4, right?
Yeah.
And then 4 times 3 times 5. Well, they're both negative. That's -4 and then -5. That makes positive.
Told you. But how is it 8 not 64?
No, 4 times 3 times 5 is 60, plus the 4 from the 2 squared is 64. Square root of 64 is. You typed it in just perfectly. I wanted to tell you, but I couldn't. X is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, and that's all being divided by 2 times a. You can already see the order there, right? It's already. So I got a 2 here and here. Got a 9 here, here, and a -7 there. I like to go -2 plus or minus something over 18. And I like to go to my calculator for this. I'm just going to try to do it here. So that's 4. Negative is going to give me a positive. 7 times 9, 63. And 63 times 4, 240.
52.
How much?
52.
252? Yeah?
Wait, but that's without the 4.
Oh.
From the square.
So the whole thing is 252?
Yeah.
Oh, that's what, okay. I was trying to do it in my head. Is there a square root of 252? Not perfect, but I'm sure there is one. So let's clean this up. Let's go 252. That's upside down cake. Half of that is 126. Half of that, 63. To divide by 3, that'd give me 21. Divide by 3. Did I mess something up? Okay, cool. So 2 and 3 get to come outside. That's actually 6. Radical 7.
It's 2 divided by 2.
What did I do?
Simplify. It's the square root of 256. Forgot to add.
Oh, so there was a perfect square. Well, this was fun though. So then this should just be 16. Cool. I could do that. Actually, we can even simplify this before we actually do the math. They're all divisible by 2. So I would go with -1 plus or minus 8 over 9. Right? So, -1 minus 8 is -9. -9 over 9 is a -1. There's one solution. -1 plus 8 would be 7 ninths. And there they are.
Wait, what does that say? -2 plus or minus what?
16.
Oh,
I didn't erase the whole last thing I had on there.
so now
A little better? Okay, cool. Sorry about the whole 252 thing. None of that. All right. Quadratic equations. Okay, quadratic equations are going to be exactly that. In this case, they're using distance, rate, time. They're creating a table out of that. The question here is saying the speed of a current is 3 miles per hour. How fast does K or K, I don't even know how to say that. Kahi. How far does Kahi row? So once you create that, of course, we know the distance is 5, upstream, downstream. If we're talking about the rate at which he rows, it's how fast he rows minus the river. And then if you're going downstream, it's going to add some velocity to that, or some speed. And of course, time is simply distance over rate. So there's those values there. So when we write an equation, time going upriver added to the time going downriver is actually 1 3/4, correct? That's what they told us, 1 3/4 of an hour. So that can be converted to 7/4 to create this equation. So it's the time going against, and the time going with is equal to that. At this point, just like we did before, rational equations, multiply everything by the common denominator, simplify, solve it for x. Here, I'll do that part. So, that means I'm multiplying by x minus 3, x plus 3, and 4. So as I distribute to this first value, the x minus 3's are going to cancel. We're going to be left with 5, x plus 3, and a 4. And then, as we multiply to the middle term, that's going to be a 5, x minus 3, and a 4. And finally, 7 times x minus 3, x plus 3. This is just 20. So that's 20x plus 60. Wow, sorry. So that's just 20x plus 60. That's another 20x minus 60. Because this is 20, right? So 20 times x is 20x, and then 20 times 3 is the negative 60. Is this confusing, the little arc I did? Okay. And I did it in red again, didn't I? 20x minus 60. And that's going to equal, this is a conjugate, which will give me x squared minus 9. Correct? So, 7x squared minus, what is it, 63? Let's bring all that to one side. I'm going to move them to the right side, guys, just because I don't want that 7x. Go ahead, sorry. 5 times 4. From this piece right here. Yeah, because that's why I did the arc. That just makes that 20. So then you distribute. Same thing with the other part. Thank you.
Wait, is the x squared minus 9, is that supposed to be in between the two? Or are you just putting it there?
This becomes that. Okay? So then I just distribute 7 to the x squared and 7 to the negative 9. Actually, it doesn't even matter where we put stuff. Do you guys want it on the left side or right side? Left side. You're used to it, huh? So, negative 7x squared. Got that guy. Plus 40 for these two. That's 0. So when we bring the 63 over, it becomes a plus 63. Then yeah, 40. Oh. Thank you. Oh, thank you. I need that.
Can I go?
Yeah, please. Have fun. Go, Cabby. Guys, there's no tutoring tonight because it's a short day. It's an early release. Yeah. Huh? What do you want to know?
I'll let you know when I get off.
Start 12:37.
Please.
Hold on, is that even, that's not even valid. Oh my god. This is from block schedule, please. Sorry.
I thought we didn't have a system. We had a system.
Yeah, because it said 45 minutes on like classes aren't 55 minutes anymore. All classes are just 10 minutes shorter. Okay, moving on.
No.
No.
Thank you.
What happened to my color? Sorry, the color went away. No, just write it down. Fine. You don't have to rush. What's up, boss?
She's over it.
Do I want you to write down the problem? Then that's the problem?
No, like the first one.
Oh yeah, once she's done with this.
Yeah, I'm done.
Okay. That?
You look good in that.
So let's see, 6 classes at 50 minutes. 6 times. There you
She
go.
actually accepted all
Plus
of
the
it.
30, 40-minute lunch.
I've only worn
I think
that
you get out at like 1:55.
You look good in that.
Is it 1:40? Oh. There you go, 1:40, bro. She just
I have my mascara and a hairspray, my arm, so does it fall off. And then when I peel it off, it's like 60% of the face.
Why is it?
So I just throw it out also. No, but I mean like early. After earlier, it's like frozen. I feel like it's really good. And we bought it. What, right? Yeah.
20, I do. I need to keep my figure.
And my mom does it, but we can still put like.
I've invested too much to let it go.
Mascara is such a middle thing. Like a whole bunch of other schools get out at like 8 or something.
Yes.
They're like, oh, you can get out 1 hour.
That's great.
Yeah. That's how you
Well, because I can't.
That's really what it is. Maybe a little bit more. Ah, don't. I work for this district.
It's a recording.
Good, buddy? Yeah, okay, moving on. So we were here. Finish it up. Do I do the quadratic or? Yes? Okay. So. Alright, so I have that equation. Yeah. Now I'm really conscious about time. Negative b plus or minus square root of b squared minus 4 times a times c. That's all over 2 times a. Got 40, 40, negative 7, 63. Negative 40 plus or minus something over negative 14. Excuse me. I'm going to use my calculator. So, 40 squared minus 4 times negative 7 times 63. 3364. Is there a square root of 3364? Yep, it's 58. So, negative 40 minus 58. That's going to give me what? Negative 90, negative 98? Divided by 14, negative 14. Yeah, so that's going to make me a positive, which that seems going to be like the reasonable answer. I forgot how to divide. How did I forget how to divide? Sorry? You can, but since I'm using my calculator, I don't mind. So I got 7 for one. Now the other one would be negative 40 plus 58. That I didn't do, my bad. That would be 18. 18, I put times. 18 divided by 14 is a negative 1.28 or whatever. So if you're talking about how fast he's rowing, would it be reasonable to say he's going at negative 1.28? How do you go negative, right? When you're rowing? But you're still going at a speed that is constant. So I can run backwards. That doesn't mean I'm traveling negative distance. I'm not going back to the future. So he'd be rowing at 7. That would be the reasonable solution here. Okay? Am I what?
Your lungs.
Oh. Moving on. So 7 is a reasonable one because you can't be negative 9/7. So bleh. Let's go. Chefs, same idea. I want to get past these problems because there's another one that's really, man, that's a lot of work. Objective 4. Solve an equation with radicals by writing it in quadratic form. Well, objective 2 was the word ones.
Yeah, so this is.
Yeah, I want to get past this problem. Oh, my bad. It used to be, they called it 4 before. That's why I want to do this. So, I've got this. I need to fix this because I want to put it in a quadratic equation. So, how do you get rid of a square root? Square it. But make sure it's by itself first. So, 2x minus 1 is equal to the square root of x. Then I can square that. So 2x squared minus 4x plus 1 is equal to x, right? Kick that bad boy over. 2x squared minus 5x. You don't let me finish, man.
Yeah, you should
No, that's right.
Shouldn't it be 4
Isn't it 4
squared?
squared?
That is a 4, isn't it?
Now it is.
Yeah, that's all. You don't let me finish. So there you go. So then you throw that into the quadratic, but make sure that you isolate that radical before you try to square it. Otherwise, it's going to make it nastier for you, and you're still going to end up with a radical in there.
Does that say 2 over x?
No, I was trying to fix my 2. It's 4. Thanks, Brandon. Got it. Well, then you plug it into the quadratic and go through that process. You want me to do that? I always want to, but I want to get through this presentation too. Let me see. I think there's more objectives, so I think we've done enough of the quadratic. Was there only 4 objectives? No, that's still objective 3. It was 4, wasn't it? Yeah. So, do you have this copy? Okay. Just kidding. Alright, let me get to, so that's the process. Quadratic, I think you guys would be good with that. Objective 4, solve an equation that's quadratic in form by substitution. So, take a look at this. It is quadratic in nature, isn't it? Okay? And I don't know if we did something in here like that. I called it U substitution. This is actually something that you use a lot in college, calculus. Is that, something nasty is in the way, so you kind of set it aside, call it a variable, and then you do the problem, and then you replace it. Okay, so that's all we're really going to be doing. So in this case, I can call U x squared. Okay? Because what I really want this to be is simply 9x squared minus 37x. Sorry, not that, just kidding. Because I'm substituting. I want this to be 9u squared minus 37u plus 4 is equal to 0. Okay? So do you see that u is simply x squared? So if I were to plug it back in, I'd be going x squared times x squared, which gives me my x to the 4th back. Okay? Now, some people, it doesn't bother them to work with that, but it just makes it nicer when you're doing something like this.
So u is x squared twice?
U is x squared.
Oh, okay.
So if I do u squared,
So then it's...
then it would be x to the 4th.
Okay.
Like this u is really just x squared, right? Which is what I want it to be. And then I can just go ahead and solve this using quadratic. And then once I get solutions, I can re-put x squared back in. Here, I'll show you. So, negative b plus or minus square root of b squared minus 4 times a times c. That's all over to a. I'm plugging in a negative 37, 9, 4, 9, right? So x equals all that. So I've got x is equal to 37 plus or minus something over 18. Second square root of 37 squared minus 4 times 9 times 4. 35. So this is 35. So that means that x is equal to, and actually it shouldn't be x because what letter am I using? I'm using u. So u is equal to that, u is equal to that, u is equal to this. So u is equal to 37 plus 35 divided by 18, which is 4. So there's 1, right? And then what's the other one? 1/9. So it really wasn't u to begin with. So what I need to do is re-plug back in. So now u to the 4th, sorry, u equals 4 becomes x squared equals 4, which means that x equals 2 or negative 2. And then when I plug it in here, x squared is equal to 1/9. So as I take the square root of both sides, x is equal to 1/3 and negative 1/3. So there's actually 4 answers here, which is the maximum allotted by my exponent. But I've got them all now. So it keeps it cleaner that way instead of having to do the not fun method.
What if it's like a cube at the beginning?
Then you wouldn't be doing quadratic. The quadratic only works for those factors of 2, right? So this one was very dual because it was a 4th. But I'll just show you another one which is very different from this one after this problem. Okay, we're good? No, just kidding. Oh, wait a minute, I got 10 minutes, don't I? No, it rings at 9:10. Usually it rings at 9:10, which means it rings at 9. Well, then I got 5 minutes. Okay,
You have 3 minutes.
my clock says 8:52 right here.
So that means 3.
Where says 52?
Yeah,
It says,
the clock,
three.
the bell rings at 55, you have 3 minutes.
If the bell usually rang at, what time did it used to ring before on a regular day? 9:10. And classroom 10 is shorter, so I'm just taking 10 off, which means it should ring at 9. They're 15 minutes shorter?
Yeah.
Oh. Well, I thought it was just 10 minutes shorter, not 15. That's my bad. All right, can I move on now?
No.
You should have been discussing. You should have been writing, girl. I can do it in 3 minutes. Yes, I can. You write a little fast.
You have 2 minutes.
I know. I'm looking at it. All right, good. So, look at this example. Oh, that's the same thing. Moving on. Here, look. If you notice, this is like an x squared, that's an x, and then of course just a number. So I would rewrite this as saying, hey, you know what? U has a value of x plus 3. Then I'm just going to say 5x squared plus 9x minus 2 is equal to 0. Oh, touche. Thank you. That's a bad habit. You'll get used to it. So I'm saying that all of this is the value of u now.
Aren't you saving x plus 3 for last? Why would it be 9 or 9 u?
Yeah, because I'm saving it for last. What am I calling this? U. So all of this gets substituted for a u. 9, sorry. Okay, then I can go through the quadratic. Negative 9 plus or minus the square root of 25 minus 4 times, what is it? I lost it. 5 times negative 2 over 2 times 5. So negative 9, 10 plus or minus 4 times 5 is 20. What? Am I ruining it?
It's 9 squared, not 5 squared. It's 81 minus 4.
Can you just redo this question tomorrow?
Well, look, the idea is there. It's just like before. Guys, have a good day. We'll see you tomorrow. And we will do it again tomorrow if you want. Thanks!